Class 2 power limited circuits are not generally required to be installed in Conduit. However, there are some specific situations where Conduit might be necessary or advisable. The National Electrical Code, or NEC, provides guidelines for the installation of Class 2 circuits. Class 2 circuits are defined as low-voltage, low-energy circuits that are designed to be inherently safe. Because of their low-energy nature, they are not considered to be a significant fire or shock hazard. This allows for more flexible installation methods compared to higher voltage circuits. The primary reason Conduit is not typically required for Class 2 circuits is that the risk of electrical faults causing fires or shocks is significantly reduced due to the limited power available. The NEC allows for the use of various wiring methods for Class 2 circuits, including cable types specifically designed for low-voltage applications. These cables are often rated for direct burial or installation in walls without the need for conduit. However, there are situations where using conduit for Class 2 circuits is still a good idea. Firstly, physical protection. If the Class 2 circuit wiring is exposed to physical damage, such as in an industrial environment or a high-traffic area, conduit can provide an extra layer of protection to prevent damage to the wires. Secondly, environmental protection. In wet or corrosive environments, conduit can protect the wiring from moisture and chemicals. Thirdly, compliance with local codes. Although the NEC does not generally require conduit for Class 2 circuits, local building codes may have more stringent requirements. It is essential to check with the local authority having jurisdiction, or OJ, to determine if there are any specific requirements in your area. Fourthly, aesthetic considerations. In some cases, conduit may be used to conceal wiring and improve the overall appearance of the installation. When selecting conduit for Class 2 circuits, it is important to choose a type that is appropriate for the environment and the specific application. Common types of conduit include firstly electrical metallic tubing, or EMT. EMT is a thin-walled steel conduit that is commonly used for indoor applications. Secondly, rigid metal conduit, or RMC. RMC is a thick-walled steel conduit that is used for both indoor and outdoor applications where maximum physical protection is required. Thirdly, rigid polyvinyl chloride conduit, or PVC. PVC conduit is a non-metallic conduit that is resistant to corrosion and is suitable for use in wet or corrosive environments. Fourthly, flexible metal conduit, or FMC. FMC is a flexible conduit that is used for short runs and in tight spaces where it is difficult to bend rigid conduit. When installing Class 2 circuits without conduit, it is important to follow the NEC guidelines for securing and supporting the wiring. The wiring must be properly supported to prevent it from sagging or coming into contact with other objects. Cable ties, straps, and other approved methods can be used to secure the wiring. It is also important to protect the wiring from damage during installation. Avoid pulling the wiring too tightly or kinking it. Use proper tools and techniques to avoid damaging the insulation. When terminating Class 2 circuit wiring, use connectors and terminals that are specifically designed for low-voltage applications. These connectors and terminals will provide a secure and reliable connection. Always follow the manufacturer's instructions when installing connectors and terminals. It is also important to properly label Class 2 circuit wiring to identify the circuit and its function. This will make it easier to troubleshoot and maintain the system in the future. Use wire markers or labels to clearly identify the wiring. In summary, while the NEC does not generally require Class 2 power limited circuits to be installed in conduit, there are situations where it may be necessary or advisable. Consider the physical and environmental conditions, local code requirements, and aesthetic considerations when determining whether to use conduit. Always follow the NEC guidelines for the installation of Class 2 circuits, whether or not conduit is used. Remember to check with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. They may have specific local amendments or interpretations of the NEC that could affect the installation requirements for Class 2 circuits. Additionally, consider the long-term maintenance and accessibility of the wiring when making your decision. If the wiring is likely to be subject to frequent changes or modifications, using Conduit may make it easier to access and modify the wiring in the future. It's also worth noting that the specific requirements for Class 2 circuits can vary depending on the application. For example, Class 2 circuits used for fire alarm systems may have different requirements than Class 2 circuits used for low-voltage lighting. Be sure to consult the relevant sections of the NEC for the specific application. When working with electrical systems, it is always important to prioritize safety. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or damage. Even though Class 2 circuits are low voltage and low energy, they can still pose a hazard if not installed properly. Always disconnect the power before working on any electrical circuit. Use appropriate personal protective equipment, such as gloves and safety glasses, and follow all applicable safety procedures. In addition to the NEC, there are other standards and guidelines that may be relevant to the installation of Class 2 circuits. These may include standards from organizations such as the American National Standards Institute, or ANSI, and the Institute of Electrical and Electronics Engineers, or IEE. These standards can provide additional guidance on the design, installation, and testing of Class 2 circuits. It is also important to stay up to date on the latest changes to the NEC and other relevant standards. The electrical industry is constantly evolving, and new technologies and installation methods are being developed all the time. By staying informed, you can ensure that your installations are safe, efficient, and compliant with the latest requirements. When designing a Class 2 circuit, it is important to consider the voltage drop in the wiring. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause equipment to malfunction or fail. The NEC provides guidelines for calculating voltage drop and for selecting wire sizes that will minimize voltage drop. The length of the wire, the ampacity of the circuit, and the type of wire all affect voltage drop. When selecting wire for a Class 2 circuit, it is important to choose a wire that is rated for the ampacity of the circuit and that is suitable for the environment in which it will be installed. The NEC provides tables that list the ampacity of different types of wire. It is also important to consider the temperature rating of the wire. The temperature rating is the maximum temperature that the wire can withstand without being damaged. In high-temperature environments, it is necessary to use wire with a higher temperature rating. In addition to wire size and type, the type of insulation used in the wire can also affect the performance of a Class 2 circuit. Different types of insulation have different dielectric strengths, which is the ability of the insulation to withstand voltage without breaking down. In high-voltage applications, it is necessary to use wire with insulation that has a high dielectric strength. However, for Class 2 circuits, the voltage is low enough that the dielectric strength of the insulation is not typically a major concern. One final point to consider is the use of surge protection devices, or SPDs, on Class 2 circuits. SPD are devices that protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line transients. While Class 2 circuits are not as susceptible to damage from voltage surges as higher voltage circuits, SPD can still provide an extra layer of protection, especially in areas that are prone to lightning strikes. In conclusion, while Conduit is not generally required for Class 2 power-limited circuits, it is important to consider the specific application, environmental conditions, and local code requirements when determining whether to use Conduit. Always follow the NEC guidelines for the installation of Class 2 circuits and prioritize safety. By understanding the requirements for Class 2 circuits, you can ensure that your installations are safe, efficient, and compliant with all applicable codes and regulations. Remember to consult with a qualified electrician if you have any questions or concerns about the installation of Class 2 circuits. They can provide expert advice and ensure that the work is done safely and correctly. Always prioritize safety when working with electricity.